Okay, in our video today we are going to be looking at the off-centered angle T. Using parallel line development, we are going to lay out the pattern for the branch line. We are going to lay out the body, and we are going to lay out the hole. Now, here's our shop drawing over here. We can see we have a lateral T that is 45 degrees and it's flat on back. Now this fitting being flat on back means we don't have any symmetry in our branch line. First thing I wanted to look at is we have 7-inch round top and bottom on the main body. We have 4-inch round on the branch line. So let's take a look at the math that has to be done. Knowing that circumference is equal to pi times our diameter, we can calculate that 7 times pi gives us 22 inches. Now, that 22 inches is the stretch out of the main pipe. Therefore, our blank size, and this is without seams, will be 22 by 15. 22 by 15. Next, we take a look at our 4-inch branch line, and our branch line is same calculation, circumference equal pi d. So 4 times pi equals 12.5664. Therefore, our branch pipe is going to be 12 and 7/12 pi to be determined. I'm not sure about the length that I'm going to get on my pattern until I've actually laid it out with the branch pattern. Now, I converted 12.5664 to 12 and 7/16 simply by multiplying my decimal notation, decimal 5664 by 12, and rounding it to the nearest 12ths, and that gave me 12 and 7/12. So, we've done the math. Our next step is to lay out an accurate working drawing, complete with an elevation and a plan view, and that will be our next step. So here we've skipped ahead to a layout of my elevation and my plan view. Now, the reason I wanted to bring this to light before I completed this drawing is simply for this reason. If I take a look at my working drawing down here, I have a 4-inch seam. Now, that 4-inch seam is not going to meet at the outside edge of the body of the main pipe. In fact, we really don't know where it is going to land. So what we're going to do now is we're going to finish drawing the rest of our elevation and plan view, and we're going to make that relationship. So let's just bring you up to speed at what we've done. Okay, I've laid out my 15-inch high tube, 7-inch round, came up 4 inches, and I brought it out at 45 degrees to a length that works. It doesn't matter as long as I'm more than 4. I'm going to end up putting a profile up here. I don't know where 4 is going to be, so we're going to worry about the finish line after I get the element lines. Now, the plan view, quite simple. Because the fitting is flat on bottom, when I flip into the plan view from my elevation view, the information for the bottom is going to go here, or back, I guess I could call that. And here's my front. And I'm looking at the front in my elevation view. Now, because I'm flat on bottom, I'm going to come off tangent to this quadrant and lay out my 4-inch round. I laid out my 4-inch round, I brought that back to the pipe. This is just a length that I picked. In reality, this is not a true length anyways because it is coming up at 45 degrees. However, what we are after with this plan view is to locate where the element lines land on the body. Once I have that location, I can bring them down and make the relationship to the element lines on the branch line that I'm going to construct right away here. So, we have a 4-inch round. I'm going to take my diameter of my 4-inch and we're just going to draw a profile view on the end of this branch. Whoops, I slipped. I'm going to profile view on the end of this branch. I'm also going to use that same radius to divide my profile into equal spaces, 6 equal spaces. I am shortening some of the description of my layout procedures for the simple fact that this is an advanced layout using parallel lines, and the basic geometric principles should be known and understood at this point in your development. If you're looking at this fitting, you should know where the element lines are. You should know what the profile is. So I'm going to extend my 4-inch pipe element lines down into the fitting. Now here's my seam. We don't really know where that seam is going to end until we make a relationship with our plan view. Now in the meantime, I want to stretch all of these lines down into the body so I can see where they are going to meet to form our miter line. Now because this fitting is flat on back, I'm going to have 2 miter lines. I'm going to have one that I can physically see at the front, which you can see in the plan view right here, and one in the back which I cannot see. In fact, 1, 2, 3, 4, 5, 6, and 7 are all in behind and will be in the hidden view. 1, 12, 11, 10, 9, 8, 7 will be the miter that I can see. I'm going to talk about numbering for a minute now. As you can see on my seam, in my plan view, I have started with 1 at the seam, and I am numbering clockwise around the fitting's circumference. I need to make that same relationship in my elevation view. So I'm going to put 1 at the seam, and I'm just going to go around the clock now. 2, 3, 4, 5, 6, 7. Now 8 will be here. 9, 10, 11, 12. My next step is to make a relationship between these 2 drawings. Now, in order to do that, I am going to extend, starting with my seam, which is line 1, and line 1 happens to meet the body right there. Where it meets the body, I'm going to bring that down, and it is my 1 line. Next, I'm going to look at my 2 line. My 2 lands there. I'm going to bring that down, and I'm going to line it up with my 2. Next is my 3. It lands on the body here. I'm going to project that down, and I'm going to line it up with my 3 right here. 3. As you can see here, I'm working around the back side. Here, I'm working around the back side. Therefore, this miter line is going to be a dotted line. I can't see it in the elevation view. Finally, my number 4 line, well, that is right on the center line because it is flat on back. So number 4, I'll bring that all the way down to my center line. Now, 5. Notice 3 and 5 are on the same line. There's my 3 and my 5. Well, here's my 5 line right here. It's going to go right there. My 6 right there. Here's my 6 right here. 7 and 1 are on the same line, and here's my 7. Next, we're going to work from 1 backwards, so 12 is almost on the fitting, and 12 is here now. $11 roughly is the same as 12. 11. Number 10. Right there. Number 9. And number 9 is the same as 11. Number 9 right there. Okay. Number 8 and 12 are the same. Here's my 12 and here's my 8. And number 7, and I've got my 7 there. So here's the back side of my miter, coming up to number 7, or number 1 I should say. Now I can see it, so it turns into a solid line, and it's going to follow those points right there. That is going to follow that like that and turn around to here. Something tells me that should be about there, but that's okay. Remember, it's following the curve of the pipe, so I'm not going to make any predictions. Okay. I have my front miter, which is 1, 12, 11, 10, 9, 8, and 7, where I can see here. I have 1, 2, 3, 4, 5, 6, 7 around the back, and there is my fitting. Now, it's important for me to realize that in my plan view, these lines are coming up at me at 45 degrees straight into the camera. They are not in their true length. Not true lengths. Not true lengths. Now, here they are. We've now found the true lengths of all our element lines. Now, what it's important now, and we're going to bring this right back to the start, our working drawing tells us we have a 4-inch seam. I can't find my finish line now until such time as I measure my 4-inch seam. So from the one point I can measure my 4 inches, which is here, and that now is my finish line. We can connect that together with our 45-degree triangle. There's my 4-inch finish line right here, and there now is my working line and my finish line with a 4-inch seam. I can't predict where that one line is going to intersect with the one line from my plan view until I have found those intersections, and then I can physically measure back to my finish line. So all my measurements for my branch pipe will have to come off of this line now to their given point here. Our next step is to lay out the branch, lay out the pipe, and the hole. From our calculations, I've laid out our 12 and 7/12 which is the stretch out of our branch pipe, the 4-inch round branch pipe. And I've also taken the liberty to divide this stretch out into 12 equal parts by using basic geometric principles. A little refresher. I found a scale that worked. In this case it was the 3/8 scale, and I stretched it from on a diagonal from 0 across to the 12, and then I marked each increment from there. I want to now project these lines up into my pattern. These are now the element lines that we so carefully laid out on our branch pipes in both the plan and the elevation view. Lots of training colleges call this the 1/12 spacing. I call it exactly that. This is my 1/12 spacing. Each one of the spaces between these element lines is 1/12 of the fitting circumference. Now that I have these lines, I need to look at my numbering. I want an inside pattern, and I have my baseline at the bottom. And quite simply, I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and back to 1. Now I'm going to grab my bow compass. And with my bow compass, I'm now going to pull the length starting with 1, and from my finish line, which is my seam, here's my 1 point. I take that to the seam, and now from 1, I lay out my 1. Next is 2. Line 2, I got to be careful now. Line 2 is part of the hidden view that I cannot see, so line 2 is to the dotted line, and I have line 2. Next is line 3. From the intersection point, I measure to my finish line, and that is line 3. 4. Intersection point of my element lines to the finish line that I measured. Once I found where the ones intersected, and here is now line 4. Line 5 starting to come back the other way. Line 5 from the intersection points to the finish line. And now I have line 5. Next is line 6. 6. Line 6 is this long. There is 6. 7. Right here. 7. And there's the length of 7. Next, we're coming back up the line. 8 is right there. Now we're working on to the miter that we can actually see. 8. Number 9. From this intersection point right here to my finish line there. And there is number 9. Number 10. To number 10. $11. And 11. And finally number 12. There's my length of 12 right there. And we have the branch pattern. I just have to color it in now. Using my trusty French curve. I'm going to bring that all the way up. And then we're going to start bringing her back down, and it's going to kind of go like this. The curve's going to come and it's going to finish off right there like that. Oh, there we have it. Don't need to put a million lines on there, but you get the idea. Let's darken out the rest of this pattern and then we can move forward. And here is my 4 on 7 at 45 flat on bottom. And this here is 4-inch round. Next step, we're going to lay out the hole onto our pipe stretch out. If I want to lay out the hole, my first step is to transfer the intersection points from my miters across through my pattern and document them, starting with number 1. Number 1 is right here, and I'm going to drag that through, and I'm going to call it 1. Next, I'm going to find number 2 right here, and we'll drag that across. Number 2. Next, number 3. 4. 5. 6. Number 7 right here. Number 8 is right here. Nine. 10. 11 is here. And number 12 is right there. This gets a little tricky, but as long as we document, everything's going to work out just fine. Next, we now know where these points are from bottom to top of our main pipe. Now we've got to figure out how they're going to intersect this way. And to do that, we're going to take a real close look at our plan view. Now, if I take a look at the plan view, the first thing I want to pay note to is the center line of the main pipe. Now I'm going to be looking at it from the inside here, looking this way, because that's what I'm seeing here is the inside of the pipe. First thing I notice is that from the center line to the left of the center line, I find 12. 12 is left of my center line by this much. We get the information for this whole spacing from this plan view. We lay out this whole plan view for 2 reasons. To find the locations here, bring them down and find our miters, which gives us our true lengths, and secondly, to get our spacings for our hole, and we're going to get them from around the curve here. Now, I started with from 12 to the center line, and I know now that 12 is left of center, so I'm just going to come over here and left of center. I'm going to put a mark, and we're going to call it 12. Now, to get to 11, I have to go back across the center line. We're going to go back to our plan view, and from 12 to 11 is this distance here. Here's 12, here's 11, it's back across the center line, that distance. So now to find 11 from 12, I have to go back across the center line. Now I've orientated everything exactly the way it needs to be. Well, from 11 I may as well find my 10. And as I can see, from 11 to 10 is almost immeasurable, but we're close. I can use it like a set of dividers, measure here, and just mark it. Here's my 10. So, let's go back the other way next. From 12 to 1. You'll see why in a minute. From 12 to 1 is this distance. From 12 to 1, from 12 to 1. Oops, that changed a bit. From 12 to 1. So now from 12, 1 has to be this way. And there's my 1. Now, from 1 to 2 is this dimension right here, almost identical to from 12 to 1. 1 to 2, here's my 1 to 2 distance. 1 to 2. Here's my 2 point. From 2 to 3. From 2 to 3 is now that distance. There's 2, there's 3, bring them in. There's my distance. From 2, I find 3. And then from 3, I can find 4 using the same idea. From 3 to 4. Okay. Now if you notice, what I've got here is one full side of the circle, from 10 all the way to 4. The other half of the circle is going to come at the bottom part of our hole opening. So my next mission is we're going to stretch these dimensions down. Here's 10. 10's a loner, it's all by itself. Here's 11. 11 pairs with 9. I can see that on my plan view. I can also see it on my elevation view. They're straight across from each other. They're both the same length. Now, I'm going to bring 12 down. I'm going to bring 12 down. That now will be my 8 line. My first line was 10. It's 10 at top and bottom. Here's my 1. 1 pairs with 7. Number 2. 2 is going to pair with 6. 3 and 5. And number 4 all by itself again. And there I have it around the clock. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, back to 1. Now if you notice here, we're going counterclockwise, and that's a good thing, because if I'm on the outside of the fitting looking in at it, I should see a clockwise rotation, which is what we did with our numbering on our working drawings. starting to make sense. Now, let's start with number 1. Here's my number 1. Oh, there's my intersection point, 1 and 1. Next, number 2 is this line here. That lines up with number 2 right here. Next, we're looking for 3, and we want to line up 3 with 3 right there. 4. Right here, I'm going to follow 4 all the way down. There's my 4 line. Next, 5. Here's 5. There's 5. Oh, look at that. 6. And 6 is here. 7 is up from there. 7 is here. 8 and 8 is here. 8 and 8 right there. Here's my 9 and my 9. It's not the one, it's not the center line, it's the one beside the center line. 10 and 10 is here. 11 and 11. 11 is the lower of those two, and 11 right there. Got to be real careful. There's a lot of lines, so we must make sure we're interpreting right. 12 is the second one down. Here's my 12 right there. I now have the hole laid out on my pipe, and there it is. So I'm going to come around the top like that. And the 10 point. Got kind of a little funny little fishtail happening here. And there we have it. I have 7-inch round. I have 7-inch round. I need to roll this 360 degrees. I'm not going to put the seams on that. You guys can do it however you want or whatever you need, however it works for your assignments. Right now what you have here is the bare stretch out pattern of an off-center angle T. If I was to cut these out and roll them up, you would get that fitting right there. It would be flat on the back, and it works every time. A couple things to remember. The numbering sequence, 1 at the seam. Another one, in the plan view, these element lines are not in their true length. We get that from the elevation view. Very important to document your lines when you bring them across so that you can follow them without too much difficulty. Important point, for our spacings, for our hole, we get that from the plan view where the element lines of our branch meet the body of the main pipe. Any questions? Let me know. I'd be more than happy to answer anything you can throw at me.